Hello learner, welcome to the learning of computer networks and security. Let's continue with the module 3 concepts. Let's start with the first routing algorithm, and the algorithm is link state algorithm. We can also call this link state algorithm as Dijkstra's algorithm. The purpose of routing algorithm is calculation of shortest path. So as we already know what is shortest path calculation, it is nothing but the best route, the shortest route from the source to the destination. So this is what we are calculating, and we will just look into the link state algorithm with an example. Okay, how the shortest path is calculated. We can just see about this link state algorithm. Here alternate name for link state is Dijkstra's, and here in the network we can just assume that all the nodes are routers. So here let's assume a network wherein we have several routers connected to this. So here we have the sender as a node, sending node, and then the destination as one more receiving node. Okay, so the sender and destination will be connected to this set of routers which are part of the network. Okay, so we have a sender over here maybe, and that sender is connected to a router. Again, this router is connected to n number of other routers. Finally, a router will be connected to some destination node. So here we have to find out the shortest path for the packet to travel from the sender to the destination node. So how the shortest path and where the shortest path is calculated? The shortest path is calculated at every router. So once the router receives the packet router's job is to find the shortest path for the packet to reach the destination. And you can just see here every router maintains the forwarding table. So we have something called as a forwarding table, and in the forwarding table we have actually the two information maintained. So one is say for example, if I take one particular router here, say let me call this as source router. Why? Because this is a router attached to the source node, and here the router source node will have two information. One is the link via which, or you can say the next hop information, next hop router via which the packet has to be transferred. So next hop is the first information, and one more information is nothing but the cost you can write. So the cost to reach from the source node to the destination. So that cost you can write, or you can also give here the information about the node, destination node. Okay, so that is about the routing table. We will see that in detail with an example. So suppose a router is far from the source node. For example, if any routers which are not neighbors of this source node, then the cost to reach that particular node is infinity. So you can just see here the cost to reach from the source node, say, to some other node which is not a neighbor, non-neighboring node, the cost we take it as infinity initially. Okay, and then the cost to reach to its neighbors, the cost to reach to its neighbors is nothing but the distance value. So the distance value here is taken as the cost to reach from the source node to its neighbors. Let us now see the calculation of shortest path by taking an example. You can just see one sample graph here, and as you all can see here, my node, source node, let me take it as U, which is directly attached to the node X, the node W, and node V. So I have three neighbors for my source node U, and then I have the link from X to Y, X to Z, and also I have this link. This is actually a link which is in curve shape. Okay, so from W to Y, and finally from V to Y. So this is my network, a small network, and you can see here these are all the routers which are connected to the network. Okay, these are all the routing connecting nodes, routers which are connected, and at every router there is a forwarding table which is maintained. And you can just see this is a table wherein the shortest path calculation is happening. Let's see step by step how the shortest path is calculated. And once my shortest path calculation is done for the source node U, then I can move on to the next source node X. So I can consider this as my next source node, and from there I can start calculation of shortest distance. Okay, so here let me show the table for a single source, that is the single source node U, from where you can now start calculating the shortest path. So before that, let's start with the list n dash. N dash is nothing but the list of nodes, wherein initially I have the single source U, and now I have to calculate the path or the distance from U to X, W, V, as well as Y and Z. To all the other nodes I have to calculate the distance. But before that, I have to see which are the initial values that I know before calculating the distance. So let me start from the step 0. So in step 0, you can see only the initial values from the node U to the other nodes. So let's see from the node U to the node V. So what is the distance from the node U to V? So it is 7. You can just see initial value is 7. So can I see that initial value 7? Yes. So the node U to V, the distance is 7. Again, the node from the node U to X, the distance is 5. And then the distance from U to W is 3. And then the distance from U to Y, it is infinity. The distance from U to Z also is infinity. So this is the initial values what we have in the graph. And now we have our step 1, the next iteration, that is step 1, wherein when I compare all these distances, I can see this is the least distance, 3 comma U, which is the shortest distance. And that means what? I have already calculated the shortest path from the node U to W, and that shortest distance is nothing but 3. And I can now say that my shortest path calculation to the node W is done. So what I can do, this node W I can add to my list n dash. So along with the source node U, now I have also calculated the shortest path to the node W. So W I can add now to the list of node n dash, so that in my next step I can continue calculating the shortest path via node W. So from source node U via node W, I can now start calculating my shortest path to the node X, then again to the node Y, and again to the node V. So via W, I can now calculate the shortest path in my next iteration, next step. So let's see how the next iteration takes place. So W is already added to my list n dash. So you can see. And now in my next step, I'm calculating the shortest path, that is not from node U via node W to V. So you can just see now, when the calculation is happening in this stage, I have two routes from node U to V. That is, one is U to V 7, which I had already updated in my previous stage. Now in my second step, that is step 1, I'm calculating the distance from node U to V via node W. So what is the distance? Cost to reach from U to W is 3. Plus the distant vector from W, that is the distance from node W to node V, it is 3. So from source node to W, the cost is 3, and the distance to reach from node W to V is 3. So 3 plus 3, it is 6, which you have to compare with again the distance that you had already entered in the table, that is 7. So that is the distance from U to V, already what we had considered was 7. So 7 and 6 that you have got just now. So compare 7 and 6, which is minimum out of that? 6 is minimum. So definitely now you have to update your table. So the new distance or the new cost to reach from node U, source node U, to the node V via the node W, the new cost is how much? It is 6. Okay, so you have to write here which is the next hop router to reach the destination node V. The next hop router is W. So the cost is 6, and we have already found the shortest path from node U to node V via W. So similarly, we can just see from node U to W, already we had calculated, right, in the previous step. So anymore no calculation. So go to the next node, U to X. So U to X, So what is the distance? U to x, the distance is 5, and then via w, if you are calculating, so what is the distance again? So 3 is the cost u to w, and w to x, the distance is 4. So 3 plus 4 is 7, which you have to compare with already entered cost 5. So out of 7 and 5, which is minimum? 5 is minimum, which we had already entered, that cost is minimum. So you don't have to update, you retain the same. So next, from node u to the destination node y. So from node u to the destination node y, the distance what you have there is actually u to w. I mean, initially it was infinity, we didn't have any information, but now u to w, the cost is 3, and from w to y it is 8. So the distance, so infinity you compare with 3 plus 8, 3 plus 8 is 11. So infinity you compare with 11, the least distance is 11. So via node w, you are now reaching the destination node y. So destination node y, and now the distance is 11. So finally u to z you are calculating. So u to z, can you by any chance can you calculate via node w? So via node w I cannot calculate the distance to z, so since I don't have any direct link from node w to z, so that is why I have to keep this as infinity itself. So at the end of step 1 you can see which is the shortest distance out of these. So it is 5 comma u, this is the shortest distance out of all. So now you have to add a new node, that is node x. We have already found the shortest distance from source node to node x via the node w. So the this particular node x, now I'm supposed to add to my list n dash. So my in my next step I have 3 nodes in my list n dash, that is u, w and x. So you can just see u, w and x are the 3 nodes in my list n dash, and now I can just start calculating the shortest distance again from the source node u to the destination node v via w and x. So this is the new path. Now I'm going to do search. So that is the shortest path calculation I'm going to do via the node w and x from source node u to the destination node v, again from node u to w via x. So do I have to calculate? I don't have to calculate because already I have found. So next I have the next one is actually u to x. So u to x also I don't have to calculate. Why? Because already I have calculated. So all that I have to calculate now is u to v, u to y and u to z. So u to v, now how do you calculate? Again u to v, now I'm going to calculate. So via the nodes w and x. Okay, so how can I calculate? So already I have a distance that I had entered earlier, so that was 6. So u to v, already I know the distance is 6 via the node w. Is there any other shortest path to reach the node v from the source node u via this node x by any chance? So here I have u to v connection from w, that is the only one, or else I have one direct path, that is the only one. Via x I don't have any path, right? So that is why I cannot calculate this distance via x. So directly what I can do there is I can say that u to v, the shortest distance is 6 only. So I can retain the same. You can just see here the distance is retained same, 6 and via w, that's the shortest. And next you can see from u to y. So u to y, is there any shortest distance via x? So just to see, now already we had considered 11 as the distance from u to y via w, but now via x we will just compare. So 5 plus 7, how much it is? 5 plus 7 is 12. So 12 is the distance, new distance that I'm getting via x, which I have to compare with already calculated distance 11. So since 12 is greater than 11, I don't have to update, keep the same distance. And now the last one, u to z, can I calculate via x? Definitely yes now. So u to z, earlier it was infinity, now via x I can calculate. So u to x I know the cost, it is 5, and x to z, the cost is distance is 9. So 9 plus 5 is how much? It is 14. So 14 is the distance I'm getting to node z, which is less than infinity definitely, and via the node x, and I'm going to update that over here. So 14 is the distance via the node x. So at the end of step 2 you can see which is the shortest. It is the distance 6 which is shortest to the destination node v from the source node u. So now all that you have to do is just add this node v into the list n dash. So my next step for my next step, I have u, w, x, along with that v also is added. And now we'll start with the calculation via node v. Again, do I have any shortest path? I have to calculate. So this is already done. Shortest path to v is already calculated. Shortest path to w also is calculated. Shortest path to x also is calculated. Now I have to see via v I have any shortest path to y, or do I have any shortest path to node z. So node y, to node y, do I have any shortest path via v? So via v I have the shortest path. Via v I have the shortest path, that is 7 plus 4, it is 11. So already I have. And then do I have any other from v? So from v, this is the only one, 11, but I have already entered that 11, so I don't have to update. Any other thing that I have to the node z via v? So via v to the node z I don't have any shortest path, so I guess I have to retain the same. Okay, sorry. So I have one shortest path, that is from node u to y. So from node u to y, the shortest path I have here is 10 via the node v. So is it right? So I have here u to v, it is u to w I have 3. So next definitely from w to v I have 3 again, so 3 plus 3 is 6, and again from v to y I have 4, so 6 plus 4 is 10. Yes, there is a shortest path. So what is that shortest path here saying? So u to v, again I know the cost via w, it is 6. This is already calculated. So from v to y, the distance I know now, it is 4. So from u to the node y, I can reach from at the cost 6 plus 4, that is 10, which is actually less than 11. So what was that 11? U to v 7, again v to y it was 4, so 7 plus 4 was 11, so which was greater. So definitely from u to w, w to v, and finally from v to y, the cost is less, that is 10 comma v, and via the node v now I have calculated the new shortest distance, that is 10 comma v. So the previous then the next one, 14 comma x, is the same. So again, out of this, which is the shortest? 10 comma v is shortest. So which node I have to add into the list? It is the node y that I have to add into the list. So in my step 4, you can see u, w, x, y, and finally the y node also is added to the list. And now you can see till here all my shortest path calculation is done, and the only thing that is left out is to the node z. To the node z, I have to now calculate the shortest path, and I have to just see via all the other nodes, is there any shortest path to reach the destination node z. So from the source node to the node z, do I have any other shortest path which is less than 14? That is what I have to calculate. So definitely I have one, and that is 12 via the node y. So via the node y, I have the distance, that is 12, and you can just see which is that. So u to w, it is 3, w to v, it is 3 again, 6. So again v to y, I know it is 6 plus 4, 10. So from again y to z, it is 2. So 10 plus 2 is 12. So this is actually the final shortest path from u to z, that is 12, which I have. And finally I can add this last node z also to my list, and finally I have all the nodes added to my list. And this is how I calculate the shortest path right from the source node u to the destination node z using the Dijkstra's algorithm. You can just see this red line marked, which is the shortest path, which I can see here. I'll just show you that separately. Here we have the Dijkstra's algorithm. I hope the example is clear. Now the algorithm also must be easily understandable. So quickly we'll have a look at it. So we have the initialization section here, wherein you just initialize the cost of the source node, cost to reach from the source node to its neighboring nodes, and the non-neighboring nodes cost should be set to infinity. So initialization is, first the set of nodes n dash will have only the source node in the list, that is u. Let's take u as the source node. Now for all the other nodes v, so maybe it is x, w, node v, node y, and node z. All the other nodes we need to initialize with the cost. So first, if the adjacent nodes you have, that is this neighboring nodes of node u, So that is x, w and v only. These are the three neighboring adjacent nodes. You have to initialize the cost. So what is the cost? You call it as the distance that you have to update now. So distance from the node u to the node neighboring node x. So what is the distance? The cost to reach from u to x is 5. So the cost to reach from node u to the node x is 5. So that is our initial distance that we have calculated from source node u to x. Similarly, the distance from u to w is 3, distance from u to v is 7. So which we update at the beginning in the first iteration or in step 0. Next, we have the other non-neighboring nodes, that is node y and node z. So where the cost to reach from or the distance from node u to node y and the distance from node u to node z is taken as infinity. So that is only for non-neighboring nodes. So once we are done with the initialization, we go to the looping section. So here the actual calculation of shortest path begins. So here onwards the loop starts. So we can see, first find a node w such that the node is not in the list n dash. So what is the meaning of that? Initially now we have in our list n dash only the source node u. Now after step 0, we need to find out a node which is not a source node, a node, different node, whose distance from the source node, the distance from the source node to that node should be minimum. So after step 0, we have to find such minimum distance. So which is that minimum distance from the source node to the neighboring node? We have the distance from source node u to w is minimum compared to u to x and u to v. So that is compared to 5 and 7, 3 is the least. So here I need to add this neighboring node w to my list n dash. So along with u now I have a new node w because the distance from u to w is least, that is 3. So we have added this w to our n dash list. Now after adding that, we have to update the distance. So what is that new distance we have to update now? Distance, that is the distance we have to update for all the adjacent nodes to the node w. So what is that we have to update now? The distance from u to the nodes which are adjacent to this node w. So which are the adjacent nodes to node w? So adjacent to w are x, v and the node y. So these are the three neighboring nodes for this node w. And now I have to update the distance from the source node u to the nodes x, y and v, which are the neighboring nodes of node w. So how do I update that new distance? So in step 1, I have to update that new distance by making use of this formula. So our formula says that minimum of the distance. So what is that minimum of the distance? First part here is dv. So what is this v? V indicates the adjacent nodes of node w. So let's take one of the adjacent node of node w, that is node x. So x is in the neighbor of w. Now I have to calculate the distance from u to x. So how do I calculate? So first you find out the distance, direct distance from d to v. So what is that? Direct distance from u to x we have already updated in our step 0. So what was that? U to x distance, that was 5. So now that distance 5 now I need to compare with the distance w. So what is that distance w? That is from u to w. The distance also I had calculated in step 0. I know that, and that is 3, which you need to add with cost from w to v. So what is that? Cost from w to its neighboring node x. Here v is the node x. So w to x, the cost is how much? 4. So already we had calculated the distance from u to x, that was 5. Compare that with the distance from U to W, which we already calculated, 3, plus the cost from W to its neighboring node X, 4. So 3 plus 4 is 7. So here out of 5 and 7, the minimum distance, so minimum out of these two values. So what is the minimum out of these two values? 5 is the minimum out of these two, 5 and 7. So here 5 is the distance that I have calculated, the smallest distance that I have calculated, that is from the node U to the node X here. So here this dv is calculated, and since in step 0 also we found that 5 was the distance, and now here in the second step, step 1, also we found that 5 is the minimum distance. So I don't have to update there the previous value, so keep the same. So now here along with this, the previous node to reach the node X, what was the previous node to reach the node X? It was node U itself, so I'm not going to change that. So from U to X, the distance is 5, list distance is 5, and through U only you have reached the node X, so that I have updated there. And similarly now you have to update the other distances also. So find now the next neighboring node of W, that is V. So again using the formula, continue there. The distance from U to V already we had calculated in step 0, that was 7. Compare with, so U to W, the distance from U to W is 3, which you need to add with the cost to reach from W to V. So the cost is how much? Again 3. So 3 plus 3, it is 6. So U to V, it was 7, and now the new distance is 6. So out of these two, the minimum distance is how much? 6. So now we came to know that the distance, least distance from U to V is 6, and we have reached from U to V via previous node W. So I need to update my previous node also to reach the node V, that is W, 6 comma W. So that is the new distance. Earlier from U to V it was 7, replace that with 6, and the previous node to reach V is W. Remember this. Okay, so this is how you have to calculate. Continue with the next node, which is neighbor for the node W. So now the distance from U to Y you need to calculate. So earlier the distance from U to Y in step 0 was infinity. So now that you need to compare with the new distance. So U to W, the distance is how much? Already we know from step 0 it is 3. So which you need to add with the cost to reach from W to Y. The cost to reach from W to Y is 8. So infinity you compare with 8 plus 3, 11. So 11 is the minimum distance. So now we came to know that the distance to reach from U to Y is 11. And via which node we have reached node Y? It is via node W we have reached node Y. So 11 and W. So this is how you have to now update. So step 1 is done. So after step 1 you compare all the 3 distances, 5, 6, 11. So remaining others also you have to see. So U to Z it is still infinity, so we don't have to update. So out of all these distances which we have calculated in step 1, the minimum distance is which one? So the minimum is 5, that is from the node U to the node X, what we had calculated. So that we have found at least. And after step 1 we have to add that, we have to find such node and we have to add that node X into our list n dash. So n dash, now we have the nodes U, also we had the node W there in my list n dash, and now the new node we have added, that is X, because we have already calculated the least distance from node U to X, that is 5. So this is how you do. And now you again go to the next continuation of calculation of shortest path. Now this time you have added the node X, right? So now you have to look for the neighboring nodes of X. So which are the neighboring nodes of X? W, Y and Z. But already I guess we have calculated the distance from node U to W, so anymore I don't have to calculate the distance from node U to node W. So now all that I have to do is the calculation from node U, source node U, to the node Y and node z, because y and z are neighboring nodes of x. So here you have to now calculate u to y via x and distance from u to z via x. So that is how you have to update the distance. So this goes on. So this is how the algorithm works. You have now the next example, one more example. This is by referring this new graph, you are calculating the shortest path. I hope this is this you can learn on your own. So how the calculation of shortest path is happening. So again, here also we have taken the source node as u, and all the other nodes you have v, w, x, y and z. So in step 0 we have calculated the initial cost, so that is only to neighboring nodes. Rest all other non-neighboring nodes distance is maintained as infinity. And after this step 0 we found the least distance is 1. So here to node x, so here node x is added to the list, and next again you calculate the distance for all neighboring nodes of x. So neighboring nodes of x are v, y and w. So these are the three neighboring nodes, v, y and w. So here v, w and y, to these three nodes you calculate the distance. So these three distances we found, and again the last to z it is still infinity. So these three new distances, out of that you found two least distance, that is from u to y and u to v, it is least. Out of these two you can add any one node into your list. So into our list I have added node y. So again u, x, y are added. So this time you are now checking for the neighboring nodes of y, that is w and z. So calculate the distance from source node u to w and from source node u to z. So u to w and u to z we have calculated the distance. So in the step 3, and out of these 3 again we found the least distance is 3. So node w you have to add into the list. So this goes on. Okay, so when exactly the iteration stops? After you add all the nodes into your list n dash. So total number of iterations here you can find, it is equal to total number of nodes. So here total number of nodes are 6. So total 6 iterations you have here in this Dijkstra's algorithm. Okay, so this is what you have to note. And finally you can just draw a graph which has the least cost path only. So here we can start with the source node u. The next node to which I have calculated the shortest path after step 0. So what is that? U to x, the distance is 1. So here I can directly add the next node x into my graph, and what is the distance, shortest distance I have calculated? U to x is 1 after step 0. After step 1 you can continue drawing. So what is that least distance I have calculated? That is from u to y I have calculated the distance, and the distance is 2. But via which node I can reach from source node u to y? It is via x I can reach the node y. So here I can add now the new node y into my graph. So via x I can reach from u to y, I can reach via x, and the distance is how much? It is 2. So already I know the distance from u to x is 1. So now it must be x to y, the distance is again 1. So that from u to y the least cost is 1 plus 1, that is 2. So this is how you draw the graph. Okay, and again after step 3 again yes, after step 2 you have found again the distance from u to v, distance from u to v, and the distance, least distance is 2, and here via u only you reach directly node v, and here I can add the node v into my graph, and here directly I can add the least cost distance is calculated is 2. So via no via node, so directly from u to v the distance is 2. So after step 3 you can find the least distance is 3, and that is from u to node w I can reach at the cost of 3 via which node? Via the previous node y. So via previous node y I have already added. Now all that I have to add is the node w. So the node w I am going to add now. So u to w you can reach at the cost 3 via the node y. Via the node y you can reach w. So via node W I can reach, but from U to Y, what is the distance? U to Y, already I know the distance via X is 1 plus 1 2, which I had already calculated. And now from U to W, via Y, I have the total cost 3. So all that I have to add is this cost 1, because U to X it is 1 and X to Y it is 1, and again now Y to W it is 1 only, because the distance calculation from U to W we have already made, the least cost is 3. So 1 plus 1 plus 1 it is 3. So U to W it is 3. And finally I know the distance, that is U to Z, the cost is 4, and now via the previous node Y I can reach Z. So I can have here from Y to Z the distance, and the cost is how much? 4. So I know that U to Y, how much it is? 1 plus 1 2. So now from Y to Z it must be the remaining distance, that is 2. So here total distance from U to Z is 4. So 2 plus 1 plus 1, it is 4. This is how you have to, now you are done with all the steps. This is how you have now to draw the final shortest path graph, which contains only the least cost distance from source node U to all the other nodes in the graph. You can just see here, this is the result of shortest path tree, that is from the source node U. That this is the graph, this was the graph which I had just drawn.